Based on what we described so far, let's take a look at how a distributed shared memory system can be designed. This type of system consists of a number of nodes, each with their own physical memory. Every one of the nodes may contribute towards the distributed shared memory system only a portion of their physical memory, or they contribute all of it. Let's assume here that only a portion of the physical memory is contributed towards the DSM service and can explicitly be addressed, whereas the rest of the memory is used either for caches or for replication or for some metadata that's needed by the DSM layer. The pool of memory regions, the memory pages that every single one of these nodes contributes, forms the global shared memory that's available for applications running in the system. Every address in this memory pool will be uniquely identified based on the identifier for the node where it's residing, as well as the page frame number of that particular physical memory location. The node where a page is located is typically referred to as the home node of that page. Now, let's say we're trying to solve the most general case where the system is supposed to support applications that have multiple reader, multiple writer requirements. For that reason, in order for the system to deliver acceptable performance and achieve low latency with which the memory accesses are performed, the DSM layer will incorporate use of caching. Pages will be cached on the nodes where they're accessed, and for a state that's cached for memory pages that are stored on these remote nodes, the home node or the manager node will be responsible for driving all of the coherence-related operations. So it will maintain state that's necessary to track the number of readers, the writers, whether a page has been modified, etc. In this way, all of the nodes in the system are responsible for some portion of the management operations for that distributed memory. The information that's maintained at the home or the manager node is similar to the kind of information that we saw that the servers have to maintain in the distributed file system example, except that in this situation, every single one of the nodes is responsible for both providing the service, acting as a server for that particular portion of the shared memory, and also being the client with respect to the other nodes. So every one of the nodes will participate in interactions with a home node in case they're locally caching some of the memory that's stored at a remote site. The home node will have to keep track of states such as whether the page is accessed, who is it accessed by, whether it's been modified. We may also choose to incorporate mechanisms to dynamically disable caching for a similar motivation like what we had in the sprite file system. Whether the page is logged, that's another useful piece of information. All this information is used in enforcing the sharing semantics that this particular DSM system will implement. When a particular page is repeatedly and even exclusively accessed on a node that's not its home node, it would be too expensive to repeatedly contact the home node to perform any necessary state updates. So one mechanism that's useful in DSM systems is to separate the notion of home node from a so-called owner. The owner is the node that currently owns the page, that's like the exclusive writer, for instance. And that's the node that can control all of these state updates and can drive any consistency-related operations. So this owner may be different from the home node. And in fact, the owner may change as whoever is accessing this page migrates throughout the system or new processes, new threads require access to this particular page. They may become owners as well. The role of the home node for that page, in this case, that was node 2, is to keep track of who is the current owner of that page. In addition to creating page copies via caching in an on-demand manner, page replicas can be explicitly created for reasons such as load balancing, hotspot avoidance, or reliability reasons so that the page contents do not disappear if some node in the system fails. For instance, in data center environments that have lots of machines, where a certain distributed shared state is managed, it makes sense to triplicate such shared state on the original machine, on a nearby machine, for instance, in the same rack, and then on another remote machine, whether it's in another rack or even potentially in another data center. The consistency of these replicas is controlled either by the home node or by some designated management node.